Welcome, infrastructure admins, to this specific NCP-MCI 7.5 exam prep explainer. Today, we're setting a steady, deliberate teaching pace for mastering Nutanix AHV guest interactions. Specifically, we're zeroing in on the baseline AOS 7.5, AHV 11.0, and Prism Central 7.5. If you're prepping for your Nutanix Certified Professional Multi-Cloud Infrastructure exam, you already know that understanding exactly how guest operating systems interact with the underlying Acropolis hypervisor is absolutely crucial. So we're going to look really closely at a topic that is virtually guaranteed to show up on your exam: VirtIO for Windows on AHV. Get comfortable, grab your notes, and let's thoroughly break this down so you are fully prepared for exam day.
Okay, let's dive into this roadmap for today. 1. The core why. 2. Detailed walkthroughs. 3. Exam traps and edge cases. And 4. Key facts.
Section 1. The core why. Understanding paravirtualization on AHV. First up, we really need to build a solid foundation of why Windows behaves so differently than Linux on Nutanix.
Before we even think about clicking through installation wizards or running migration scripts, we have to grasp this core difference, because it's literally the key to answering scenario-based questions accurately on the exam. Let's explicitly define our core acronyms here. AHV stands for Acropolis Hypervisor, which is Nutanix's native enterprise-grade virtualization solution. VirtIO, on the other hand, is a collection of drivers for paravirtualized devices. And listen, these drivers aren't just nice to have. They drastically enhance the stability and performance of virtual machines running on AHV. The fundamental challenge we face, and the main reason this is so heavily tested, is that unlike Linux, which has native kernel support for these paravirtualized devices built right in, Windows completely lacks native kernel support out of the box. Without these drivers, a Windows guest simply won't know how to talk to the AHV virtual hardware efficiently. Or worse, in the case of the storage controller, it won't even be able to see its boot disk at all. It'd be like trying to read a book in a language you don't speak.
Looking at this direct comparison from the Nutanix Best Practices Guide, you can see a really clear distinction between two completely different Nutanix toolsets. Notice that for creating a new Windows VM, VirtIO is marked as a strict yes, while Nutanix Guest Tools, or NGT, is marked as no. NGT provides advanced features, things like VM mobility, VSS integration for application-consistent snapshots, and self-service restore. That makes it entirely optional. However, the VirtIO driver installation, that is strictly required just to make the VM function properly. Contrast that with Linux, where VirtIO's support is already baked into the Linux kernel and enabled by default. So definitely memorize this distinction. NGT is optional for advanced features, VirtIO is mandatory for Windows survival on AHV.
Section 2. Detailed walkthroughs, manual builds, and move migrations. Let's look at how we actually apply this knowledge and get those drivers injected into the Windows guest.
It's one thing to know Windows needs these drivers, right? But the exam is absolutely going to test your operational competency. We're going to explore exactly how these drivers get injected during manual builds from an ISO, and also during migrations using Nutanix Move. Imagine you're hand-building a brand new Windows Server VM on AHV. You've mounted your Windows ISO and the Nutanix VirtIO ISO. Because Windows doesn't natively recognize the AHV SCSI controller, the installer won't see any hard drives to install the OS onto. You literally have to intervene. First, you select Custom Install Windows Only. Next, when you hit that empty disk screen, you click Load Driver and then Browse. You'll navigate to the mounted VirtIO CD drive. Now here's a critical exam detail. You must carefully select the specific directory for your OS architecture. The x86 subdirectory is strictly for 32-bit Windows, while the AMD 64 directory is for 64-bit Windows. Once you're in the correct folder, you are hunting for the SCSI pass-through controller driver, specifically the VO SCSI IONF file.
And this brilliantly illustrates exactly what that looks like in the Windows setup interface. You are pointing the installer directly to that VOSCSI.in file inside the AMD 64 folder for Windows Server 2019. Once selected and you click Next, boom, Windows suddenly has the translation layer it needs to see the virtual SCSI disk provided by AHV. From there, the installation can proceed normally. I can't stress this enough. This single step is the most common hurdle admins face when migrating to AHV manually for the very first time.
Once you're fully logged into the VM, pulling up the device manager allows you to verify a successful installation. You really want to confirm 3 main components are present and functioning perfectly without any errors. Under Network Adapters, you should see the Nutanix VirtIO Ethernet adapter. Under Storage Controllers, you'll see the Nutanix VirtIO SCI pass-through controller we just injected. And critically, under System Devices, the Nutanix VirtIO Balloon driver. Seeing these three confirms your VM is fully paravirtualized and optimized for the AHV environment.
Now, hand building from an ISO isn't exactly how we migrate at scale, is it? For that, we use Nutanix Move. When you're configuring a migration plan in Move, you're given a choice for VM preparation modes. In automatic mode, Nutanix Move automatically connects to the source VMs and runs the necessary preparation scripts seamlessly behind the scenes. In manual mode, Move simply generates and displays the preparation scripts, and it relies on the administrator to copy them over and manually execute them on the respective source VMs. You can even use a mixed mode if you happen to want a hybrid combination within the exact same migration plan.
But what do these Nutanix Move preparation scripts actually do under the hood for a Windows instance? Well, this is highly testable material. When the script runs against a Windows VM, it executes a very specific workflow. First and foremost, it forces the installation of the Nutanix VirtIO driver, solving our paravirtualization problem automatically, skipping the standard driver installs for Linux but absolutely forcing them for Windows. It then runs an IP address retention script to ensure networking stays perfectly consistent post-migration. Next, it runs a script to set the SAN policy. And finally, after the hypervisor conversion to AHV is totally complete, it runs a script to uninstall VMware tools, cleaning up all those legacy hypervisor drivers. It basically handles all the heavy lifting you would otherwise have to do manually.
Section 3, Exam Traps and Edge Cases. Here is where many admins get tripped up, so let's shift our focus to some troubleshooting and gotchas.
The exam rarely asks about a perfect happy path installation. They're going to present you with a scenario where something went completely wrong, and you have to identify the root cause based on Nutanix documentation. Pay really close attention to this direct warning. VSS, or the Volume Shadow Copy Service, is the Windows framework for taking application-consistent backups. If a guest VM has multiple lingering Windows VSS snapshots present on the system, the VirtIO installation or upgrade is known to fail. Why? Because the presence of these multiple snapshots causes a specific timeout to occur right in the middle of installing the Nutanix VirtIO SCSI pass-through controller driver. So, if an exam scenario mentions a failing VirtIO upgrade and casually drops a hint about backup software or snapshots, you now know exactly what the culprit is.
Here's a highly testable piece of legacy operating system trivia for you. If you're dealing with very old environments, specifically Windows 7 or Windows Server 2008 R2, you cannot just inject the VirtIO drivers out of the box. No way. These operating systems actually require you to first install Microsoft KB303929 or ensure the OS has the latest Windows updates to enable support for SHA-2 certificates. The newer VirtIO drivers are signed with SHA-2, and without that specific KB, the legacy Windows OS will reject the driver installation entirely due to signature validation failures.
Let's pivot to memory for a second. Windows VMs absolutely do not have a memory balloon driver by default. To make one available so the hypervisor can reclaim memory during idle periods, you must manually install the VirtIO driver package, or have installed Nutanix Guest Tools version 2.1.1 or later, which embeds that VirtIO package. Without this balloon driver, AHV just cannot effectively manage overcommitted memory within that specific guest. Speaking of overcommitment, industry-standard vCPU oversubscription practices dictate that you should not oversubscribe more than a 4:1 ratio when starting VMs. But memory oversubscription, that is where things get truly critical, especially in Windows environments. So, if you choose to oversubscribe memory, which, by the way, Nutanix generally only recommends for non-production use cases, you absolutely must configure the Windows VM swap space to be strictly equal to the configured RAM size of the VM. Here's the why behind that rule. Because overcommitted VMs give up part of their memory during idle periods, that memory might not be available immediately when a VM suddenly wakes up and requires a huge chunk of memory again. The VM might actually run out of memory before AHV can react and reassign it, causing the OS to just unexpectedly shut down your applications. Having swap space equal to RAM provides a temporary overflow area, basically keeping your applications from crashing while AHV provisions the needed memory. One final operational gotcha regarding updates. As an admin, you might push silent updates using the NGT installer via the command prompt, utilizing the /no restart flag to prevent unexpected downtime during business hours. While this command successfully updates the VirtualIO drivers on the disk to the latest version, the updated functionality of those VirtualIO drivers is strictly pending. It won't take effect, and the VM will not utilize the new drivers until you go in and manually restart the VM during a maintenance window.
Section 4. Key Facts. Let's review the most critical, high retention points to lock in for exam day.
We've covered a lot of deep technical ground today, so let's run through these final points with clear, steady pacing. Number 1, Windows demands VirtIO for basic operation on AHV, whereas Linux has it native in the kernel. Number 2, for manual OS installs, you must actively inject the VirtIO sci.inf driver to even see your boot disk. Number 3, multiple lingering VSS snapshots are the primary culprit for VirtIO installation timeouts. And number 4, a detail we haven't highlighted yet but is super essential. Starting from Nutanix VirtIO driver version 1.1.5, the driver package actually contains WHQL certified drivers for Windows. WHQL stands for Windows Hardware Quality Labs, meaning Microsoft has rigorously tested and cryptographically signed these drivers to guarantee stability in the Windows ecosystem.
I want to leave you with this provocative question to make you evaluate your own production cluster setups. Are your current Windows Golden images and templates actually running the latest WHQL certified VirtIO drivers, or have they been neglected, meaning you're risking silent stability and performance issues across your clusters? Understanding this material doesn't just help you pass exams, it builds incredibly resilient infrastructure. Thanks for joining me for this explainer on NCP-MCI 7.5 VirtIO for Windows on AHV. Best of luck on your certification exam.